really noisy inside here, so I'm going to need some ear protection. That's better. A power station like Rugeley uses the same science of electricity. It has at its heart two enormous alternating generators, which are made of coils of wire and magnets. Now, when these are turned, it generates electricity, which is fed out to our homes over the national grid. The big difference here, though, is size. These things are massive, and they need a lot of energy to turn them. And that is where coal and steam come into the story.
To better understand the science behind steam, I need to be here in the lab. But first, I need to change. Power stations have to get their energy from somewhere to turn the massive generators. Now, Rugeley uses coal to produce steam, and it's the properties of steam that make it particularly useful in making machines work. This is a Hero's engine, invented by a bloke called Hero some 2,000 years ago in Alexandria. Now, in its day, it was nothing other than an expensive toy, a curiosity for rich people. Hero discovered that if you create a fire under the vessel that contains the water, it starts to boil. And as the steam escapes through the opposing arms, the whole vessel starts to rotate. Now, although they didn't truly understand all the processes involved, this toy displays much of the science that is used in a power station like Rugeley. Question: what temperature does water boil at average sea level? Rugeley is a coal-fired power station. It uses coal to produce or raise steam, which in turn turns the turbines, which turns the generators.
But unlike a Hero's engine, the power station is both massive and complex, mainly due to it having to be as efficient as possible. Laws of thermodynamics, number 1. Energy is not lost or used up, it just changes form. Or in other words, the amount of energy always stays the same. Power stations are really interested in converting as much of the energy in coal into electricity. The more coal energy converted into electricity, the less coal is required, which makes the electricity cheaper and reduces the environmental impact. But there's a problem inherent in all heat engines, whether a car engine, a steam engine, or a power station. And that's because of a law known as Carnot's law.
It is impossible to have a perfect heat engine, where all of the heat energy is turned into mechanical energy. This law can be regarded as an informal statement of the second law of thermodynamics.
The best way to make a power station as efficient as possible is to use the best coal and to burn it as effectively as possible. The subsequent heat used to create steam at very, very high temperatures. But why such high temperatures?
As we already know by now, water boils at 100 degrees Celsius, but not everywhere.
As all good mountaineers know, it's quite difficult to make a really hot cup of tea on the top of a mountain. Now, that's not because it's windy and cold, it's because of air pressure. The higher up a mountain you go, the lower the air pressure, and this affects the boiling point of water. At 10,000 feet, the boiling point of water reduces to 90 degrees Celsius. At 30,000 feet, on top of Mount Everest, the boiling point of water reduces to 69 degrees Celsius. And there we have it. Anybody for a slightly lukewarm cup of tea?
From this example, we can deduce that low pressure equals a lower boiling point, and conversely, high pressure equals a higher boiling point. The power station uses very, very high temperature steam to try and overcome some of the problems resulting from Carnot's law. The power station here at Rugeley uses steam at very high temperatures by boiling the water at high pressure. High temperature, high pressure steam helps make the power station much more efficient and reduces the cost of the electricity.